So for today's lesson, we'll talk about precipitation reactions. Yesterday we started with chapter 2. In chapter 2, we talked about the compounds in aqueous solution. We said if ionic compounds, until now we are only talking about ionic compounds. If ionic compounds dissolve in water, they will separate into the ions, and we talked about their moles. How can we find their moles? And we solve the practices as well. Now, we'll talk about precipitation reactions. Precipitation reactions talks about or kind of explains which compounds will dissolve and which compounds don't dissolve in water. So we talk about how soluble a compound is, especially for ionic compounds, of course. So for ionic compounds, we have 6 rules. Even though no ionic compounds is completely insoluble, like every ionic compound, we consider them as slightly soluble, but for the low solubility, with the compounds which have a very, very low solubility, which they don't dissolve a lot, we consider them as insoluble. In order to understand this, we have these six rules, which will let you to know if the compound is soluble or not. We have the 6 rules. I can say that it has been separated into 3 categories. Let's look at rule number 1. So these are the guidelines in order to know if a compound is soluble or not. Will it dissolve in water or not? So this is general guide for ionic compounds solubility in water. Now, the first rule: all compounds of sodium, potassium, and ammonium are soluble in water. What does this mean? It means that any compound that contains any of those 3, you can directly say it is soluble. Again, any compound, if it contains sodium, potassium, or ammonium, you can directly say it's soluble. For example, let's say we have not here. Let's say we have NH4Cl. See, you will look at it and you will say there is NH4. So directly, without anything, don't look at the other substance, don't look at the other element. Since it contains NH4, it is soluble. Or let's say you have K2SO4. Without anything, since it contains K, it is soluble. What else? Another substance, for example, Na2CO3. Directly, you don't look at the other stuff. As long as you see Na, it is soluble. All right. Same thing for rule number 2. Rule number 2: anything that contains, so these were for the cations, these 3 cations, but these 3 are for the anions. Anything that contains nitrates, acetates, chlorates, directly you can see they are soluble. So for this is number 1, this is number 2. Let's say you have AgNO3. We don't have a rule for Ag. So you will directly look at NO3 and you will say, since it contains NO3, it is soluble. Or let's say, what else do we have? PbClO3. This is Pb2. Without a hinge, you can directly say it is soluble. Why? Because it contains ClO3. That's it. So anything that contains these 6, we can directly, without any exceptions, you can say they are soluble. So rule number 1 and 2, these 2, they are always soluble. always soluble. If they are in a compound, they will make that compound to be soluble. هذا حركاتي أو دور أو جماعتي لنا أو دور الله لقل هر compound يكابون لقل هر compound يكابون يكسر لنا soluble يكسر. What about rule 3 and 4? Let's look at 3 first. 3 is like specific for Cl. You can also say it's also can be specific for Br as well. In the book, it only says Cl, and questions will be asked about only Cl. But Br is also just like Cl. Iodide is also like Cl. So these 3 are the same thing. But for now, we are just focusing on the Cl. We especially focus on the Cl. They are generally soluble. See, until here, that's the point where we look at after. Until here, they are soluble. But if they come with Ag, any Ag, like we have one Ag, sorry, silver. If they come with silver, if they come with mercury, if they come with lead, which lead? Lead even 2 and 4. All right, there must be a 4 here. That's a problem. We have lead 4 and lead 2. All right, so even with mercury, silver, and lead, those 3. If they come with those 3, except when it says except with silver, mercury, and lead, it means that it will be insoluble. So these compounds are insoluble, except for what? PbCl2 is insoluble. It's insoluble, but it is only soluble in hot water. Only soluble in hot water. So AgCl, this solid means it is insoluble. It becomes precipitate. So it's coming with silver. Cl with silver, insoluble. Mercury with Cl, again, insoluble. PbCl, like both of the leads, Pb with Cl, any Pb with Cl, it is insoluble. Except if it specifically tells you only PbCl2, like lead 2. Only lead 2 is soluble only in hot water. All right. So again, rule number 3: Cls, Cl negatives, chlorides are generally soluble. But if they come with silver, if they come with mercury, if they come with lead, you can say they are insoluble.
أوصل soluble ما بس لنا أوا
لنا أوا ها تلسر مثلا توما لنا أوا بس ما لنا أوا باشا. All right. The next one is also like Cl. Like that's why I have separated the 6 rules into 3 different categories, to 3 different groups. So number 4 is also the same thing. SO4 are generally, like sulfates, are generally soluble. Except with what? Except with 5 things. Except with barium, with strontium. So you have to, it's better to memorize the elements that it becomes precipitate with them. So barium, strontium, lead, any lead, even lead 2 and 4. So this is lead 4. I'm a lead 2. I'm a lead 2. This is lead 2. This is lead 4. So any lead, and calcium and mercury. All right. So reacting with, or like having with each one of them, like for example, sulfate with barium, insoluble. Sulfate with strontium, insoluble. Sulfate with lead, any lead, lead 2O4, insoluble. With calcium, insoluble. With mercury, insoluble. All right. So these 2 rules, we can say generally soluble, except with some element. درام بسم چیه؟ يعني بعم soluble بلان بيج قال لقل كان element هيك. For example, Cls are soluble except with mercury, silver, mercury, and lead. Same thing. Sulfates are soluble except with what? Except with barium, strontium, lead, calcium, and mercury. How can you make an hour? All right. Number 5 is exactly opposite of 3 and 4. These 3, phosphates, silicates, and carbonates, they are generally insoluble. They are generally insoluble. Except with what? They become soluble with what? With the elements of group 1. Why? Because group 1, so they are negative, negative, negative. So if they make a bond, if they make an ionic bond, if they make a compound, they will make it with a cation, with a positive. اخوان negative اگر bond درست کنن اگر لگش چکی ترابن بلگه positive ابن كواتا لگه كان positive يعني اگر بين soluble يعني group يك بو يبي group يك because group 1 they don't care about anything, they are always soluble. They are always soluble. So CO3, PO4, if we see them, we'll see they are insoluble with something else. But if they come like this, CO3, see these are all the examples. You don't have to memorize the example. You just have to know the elements and the ions. For example, you know CO3, PO4, and silicate, they are insoluble. But if they come with, you have memorized group 1. If they come with sodium, potassium, or ammonium, anything like that, for example, like here, CO3 is insoluble. If it comes with sodium, see it has written AQ. AQ means soluble. See, the AQ indicates that it is soluble, but the S indicates that it's insoluble. Again, PO4 is insoluble, but if it comes with ammonium, potassium, and sodium, soluble. Same thing. Silicate, if it's insoluble, but if it comes with the group 1 elements, so from the rule 1, ammonium, potassium, and sodium, they become soluble. They become soluble. So they become soluble only with only Na, K, and NH4. تنها لقال أو شوارع لقال الثانية بقولن soluble. All right. Now, the last rule also, most sulfides, sorry, not sulfates, sulfites. Be very careful. This one is sulfate, SO4 with a charge of -2, sulfate. This one is sulfide. This is monatomic, this is polyatomic. It's exactly opposite sulfate. Sulfates are generally soluble, except with these 5. Sulfides are generally insoluble, except with what? Except with 5 things again. Ca and strontium, and of course, which elements, which things are always soluble? Sodium are always soluble. K, potassium are always soluble, and NH4. So sulfides are just like 5, the rule 5, which they are insoluble except with these 3. So the same 3 are also like present here. The same 3 are present here. You only have to add 2. So that's how you memorize it. You memorize one thing and use it in another. For example, you have memorized group 1, like rule 1. When you memorize rule 1, for 5, you can directly connect them so that you can say they are insoluble except with rule 1 elements. That's it, except with rule 1 elements. 6, they are insoluble except with what? Rule 1 elements plus another 2, plus another 2. So they become soluble with calcium, strontium like this. So calcium sulfide, see, calcium sulfide, soluble. Strontium sulfide, soluble. Sodium sulfide, soluble. Potassium sulfide, soluble. And ammonium sulfide, soluble. So that's how you can memorize these 6 rules. So rule number 5 and 6 generally insoluble, except with some elements. كواتا أهم بو أم چی بو بعام insoluble بون except بيج قالوا لقى مجموعة هشتاك أبدا هاو كردوم بس يبشر كواتا بشي يكم كتولا وريان كلا معنا قام insoluble بشي دوم ألين بعام دو دانه سيالو صفارة بعام soluble بالام لقى شيء soluble نين يقدوش تهي تقريبا ثابتين لدو ميركوري مثلا لريا مثلا السيلفر وميركوري وبلات ناي إليمنتك هن لبركة تو خود كونكتيانكا كبيني دي ترزاني ليرش الصلفات ناي بينج إليمنتك لبركة barium, strontium, lead, calcium, and mercury. For rule number 5, you have CO3, PO4, and silicate or SiO3. These are insoluble except with what? 3 things. What are those 3 things? The ones from rule number 1. The ones from rule number 1, because rule number 1 elements, they don't care about anything. They are always soluble. They are always soluble. That's why when they come with CO3 or PO4 and SiO3, they are also soluble there. Rule number 6, we have sulfides, which are insoluble, and they are soluble with the elements of group 1. This is from group 1 or rule 1, plus another 2, which are calcium and strontium. Basha Baba. Any questions?
مثلا بس لخالي 3 و4 توزق نحالي يعني جان تينا قشتم لي 3 و4
3 و4
والله
باشا 3 و4 ClSO4 معناها Cl بعم soluble يعني بون من قشتك لقل Cl بيني يعني Cl لنا كومباوند كابيني بلا soluble بالا ما قال Cl لقل أما مجموعها بيني تونات يعني بلا soluble عشان أكثر بلا شيء insoluble لقل شيء لقل سيلفر بينيو Cl لقل ميركوريا بينيو لقل قرقش مشابينيو ليد كواتما أبي أكثر ب insoluble أها شيء بدانا اسم بدانا كواتبو إسانة بشيء ب insoluble بلام mass compounds of sulfate أي نشتيش لتشوارم مش السلفيت لبري Cl أم جانا السلفيت علين بعم soluble بيج قال شيء accept أجر لقى باريوم أبو لقى باريوم أبو يعني باريوم سلفيت لقى سترونتيوم أبو لقى بي بي أبو هاد بي بي بيت بي بي دو بيان بي بي شوار بيت لقى كالسيوم أبو لقى ميركوري أبو لقى هاريك لما أبو أو كاتة تو يكسر أتواني بلي أما insoluble الناتو تو يكسر أنيش اللي جركه
أي بينجميج يعني لقل أمس يعني soluble بيوايا
بلا تنجم
أنا بس
عدد أمس يعني insoluble سيرك أجر CO3 لكمباوند كابينو insoluble PO4 insoluble SiO3 insoluble بلا ما جر هاتو لقل جماعتي رول يكم أبو شو كرول يكم حسابه هيش تناكن رول يكم ببيه هيش تجسد دام soluble فاتك لقل أوانا بنا لنشيا على insoluble
يعني الهاشتاج هاي بقري إجابة soluble
لقل هاشتاج يقول إجابة soluble.
Okay, that's
Any more questions? Don't worry, we'll solve a lot of more questions and you'll gradually understand how it works, all right? But it's very, very important. Like you need this table for at least 4 grades in ministry. 2 درجة و 4 درجة توليريها حاصلة كلهم تبلع. اگر هنه جار زیاد تریج نبی یعنی با تیگشتی موضوع تیج جاری وایه اما پیویست من پیر بید كل chapter حوتي شا پشت بم تیبل عبسته alright notes. Of course, these rules are useful in predicting what will happen if solutions of 2 different soluble compounds are mixed. We'll talk about this later, how it works. If the mixing results, so let me explain these three together between, like in an example. From now on, so if something is soluble like this, so this is solid, all right, all ionic compounds, all ionic compounds are solid before they get dissolved. همو ionic compound یک solid پیش بیتون اینا، یعنی اگر پیش بگات سر که بیتون اینا همین solid همین. So something like ammonium sulfide, which is an ionic compound, if we dissolve it in water, it becomes ammonium and sulfide, and they are aqueous. Same thing for cadmium nitrate. See, it contains what? Ammonium from rule 1, so it's directly soluble. Same thing, it contains nitrate from rule 2, it's directly soluble, so it becomes cadmium and 2-nitrate. So from now on, instead of always writing the ions separately, we can do this. Everyone, please pay attention. We can do this. We can write NH4 by 2 and S aqueous. If you see this aqueous, you can directly think that then this ammonium, this solution is already what? Is already or has already become ions. Is already dissolved. Is already or like has already contains or the container contains NH4 and sulfide. كواتا كورنا لمولا اگر بيتو امونم شتيشوات بينيو لتنشتو IQ نسرابو يعني already بوباي. Then why do we write that? Why don't we write the ions so that we can write it more easily, so that it doesn't take a lot of space, and it's better to recognize it, and it's easier to recognize it. Same thing for cadmium nitrate. So if I say it is cadmium nitrate, then aqueous, it means that it has already dissolved in water. It has already dissolved in water, and it contains cadmium and nitrate ions. Cadmium and nitrate ions. What do we use generally? What do we use these rules for? The 6 rules. It's useful for predicting what will happen if 2 different soluble compounds are mixed. Two compounds take up. If the mixing results in a combination of ions that forms insoluble compound, a double displacement reaction and precipitation will occur. This reaction is called double displacement reaction. Double displacement reaction. What is double displacement reaction? It's where these 2 compounds, when they react together, we change their cations places with the anion places together. So if this is a cation of the sulfide, now this cation will become the cation of this anion, like this. This is what is going to happen if, let's say, AB, this is double displacement reaction. I don't know if you remember, but I'm just gonna explain it anyway. If AB reacts with XY, all right, XY. So the one on the left, these are cations. This is only for ionic compounds. These are anions. When they react, they change places. دور رفيق بين أوشان دور رفيق به يكي ركانا بقرنا أو بلا رفيقه تو بلا من رفيقه مش بيبشوا بلاته. What will come to the reaction? The A will react with the Y because A is cation, and we always write cation on the left. So it becomes AY, always. See, cations are on the left. Now, but this time A is with the Y, not with the B. This time the X is with the B. All right. So they change places. They change places. What is this used for? This we call this reaction double displacement. See, double displacement, because both of them change places. That's why it's called double displacement. For this substance, for this reaction, let's look at here. What's written here? Aqueous. So if it's aqueous, it's already what? It's already ions. NS4 unsulfide. Cadmium nitrate is also aqueous. So it's already has become ions, but we don't write the ions so that we can see them more easily. We can work with them. We can write reactions more easily. When we mix these two, how is this possible? Or how does this look like if we do it in real life? So when it says like this contains ammonium sulfide. Another container contains cadmium nitrate. In the ammonium sulfide, it means that it is soluble, it's aqueous. This one is also aqueous. It means that it contains what? It contains NH4 and sulfide. This one contains, it means, this aqueous means it contains cadmium and nitrate. See, it contains ammonium sulfide, ammonium unsulfide. This one contains cadmium and nitrate. We pour both of them into another container. Let's say we mix them together like this. We pour both of them into this container. So what are we mixing? We are mixing 4 ions. 2 ions from this container, which is ammonium sulfide. 2 ions from this container, which is cadmium nitrate. And together we have 4. All right. And then we will look at them, whether these 4 ions react together or not. Would they react together or not? If they don't react, so all the ions remain the same. Again, if they don't react, if there isn't any attraction, then there is no reaction. They all remain as ions. But if there is a reaction, we have to know about it. In the third note, before I write this down, look at the third note. If after mixing, what might happen? Precipitation might happen. There may be a precipitation. Why? Because the attraction between ions is greater than the attraction between ions and surrounding water. If the 2 ions, so how did these 2 ions get separated in ammonium sulfide, for example? Because the water has separated them. Attraction of water was high. But what if the water cannot attract doesn't have enough attraction against the attraction between the ions? How? If I write a reaction like this for double displacement, again, ammonium with nitrate, so it becomes ammonium nitrate. The cadmium with the sulfide, just like the AB and XY I have written here. That's how you do it. عكس يعني كده. شو أنا كان بقوله. أتواني بقول دوانكي قبلين أوي دوانكي كلا شافون شو أنا كان بقوله رد درجات. ياخد دوانكي لا الرأس شو أنا كان بقوله فرق ناكت. Gringo لا الراس لقط لا الراس تبغورته لا يشوف لقط لا يشوف بغورته. Gringo. Now, I have left this in order to know if they are soluble or a precipitate has occurred or a precipitate has been formed. We have to go back to the rules. We have to go back to the rules. Like this. Ammonium sulfide, when reacts with cadmium nitrate, it will produce ammonium nitrate and cadmium sulfide. Let's start with the rules. This one contains ammonium. ammonium, it's in rule 1. If you see them in anything, it's directly soluble.
Soluble.
Yes. Even for NO3, which is in rule 2. If you see them in any rule, it's directly soluble. So you can directly say this one is AQ. So yes, this one is soluble. Until now, there
مثلا
is
IQ يعني إسا يعني IQ يعني soluble okay إسا كي.
Bale. So if we look at this one, we don't have a rule for cadmium, but we have a rule for sulfide, S, right? S is generally insoluble, except with what? Except with calcium, strontium, ammonium, potassium, and sodium. But it's not with any of them. It's not with something that makes it soluble. That's why cadmium sulfide is actually a precipitate. So cadmium sulfide becomes a precipitate. Cadmium sulfide will be precipitated. Later, this time, yes, the reaction has occurred. Why? When we mix these two solutions together, so this is a solution. When we mix them, the ammonium, because it's aqueous, and the nitrate are still soluble. They are still remaining as ions. But the cadmium and the sulfide they have attracted each other because there's a strong attraction between cadmium and sulfide, and the water cannot separate the cadmium and sulfide away from each other. That's why they become solid, and then this is a precipitate that is formed by mixing those two solutions. كاتبة دوباره كم وقتا لمولا إما بموضوعات شي معنويت reactionك معنويت أجروتي precipitation reaction بتشي روايات إما علين double displacement reaction. Please underline this part, double displacement reaction. Underline يكي highlight يكي شي يكي like this. Double displacement reaction. Okay, so precipitation reactions occur as double displacement reaction. How is that possible? شلون أمابت؟ Two soluble solutions. Whenever we say solution, it means it is soluble. Two soluble solutions, two soluble compounds. We mix them together. Two soluble ionic compounds. We mix them together. And we will see if a precipitate occurs or not. How do we know? First, we have the two solutions. We have the two ionic compounds. We change places for a possibility to see if it works or not. We change places. You can do what? You can change the places of the cations like this. For example, this cation with this cation. Or you can change the anion with the anion. Anion, cation, فان شوية كان بقريته. شو ما كردوه؟ أو شوية cation كان ما قريته. أي كان بردوته لا يوايكا. Extraction بردوته لا بيكا. فرقنا كباشو بيشش بالنسيكم. It doesn't matter if I write this. This is also true. XB plus AY. It doesn't matter. It's the same thing. As long as there is a plus here and it's XB not BX, as long as it's AB not YA. So for example here, as long as CDS not SCD. Why? Because cadmium is the cation. Sorry. Cadmium is the cation. Sulfide is the anion. So sulfide always must be the one on the right. That's why sulfide is on the right, is the anion. So when you write it down like that, and you go back to the 6 rules and decide if the reaction is soluble or not, or the substances are soluble or not. We'll try to solve more questions afterwards. We have many more questions, and we'll put something else, also more things, another subject with this solution as well. Basha Kurina. All right. The next thing is also connected to this part. It's kind of the same thing, but we add some more stuff. Net ionic equation includes only those anions that undergo a chemical change in a reaction in an aqueous solution. So we have a net ionic equation. There we have an equation. In that equation, only the things we leave, let's say like that, we leave only the things that can be or that can undergo a reaction. The other stuff we just cancel it, we just delete it. All right. For the other notes, I'm going to explain it when I solve this reaction again. So look at how I'm going to solve this reaction. This is the same reaction as above, same thing. So that you get used to it, that's why I use the same thing, the same reaction. Let's say cadmium nitrate with ammonium sulfate. See, it doesn't matter if I write one of them before or the other one after. In this chapter, as I told you, it's very important to know the table. As you can see, there was the other question about the moles, and you have to know the tables, naming of the compounds and formulas. Same thing here. Sometimes only the name is given, not the formula. Now, when it says cadmium nitrate, let's see cadmium nitrate. So it's CdNO3 by 2. This is, of course, aqueous. It is soluble. And it says for the solution of these two, then it becomes NH4 2S. This is also aqueous. When we mix them together, see the cadmium and the ammonium, we can change their places. It becomes ammonium nitrate, aqueous. Sorry, that's not right, the aqueous now. Like this, plus cadmium nitrate, cadmium sulfide, Cd. Now the Cd and these two change places, so it becomes CdS. Again, ammonium and nitrate, you can balance it also. We have, when you balance double displacement reactions, you please look at these for the atomic ions as one unit. So when we say we have two nitrates, same thing, look at the nitrate all together. When you say we have two ammonium, look at the whole NH4. Don't look at N individually. Don't look at H individually. Look at the whole NH4. Since the NH4 is on both sides, so we have two NH4, we have two NO3. If we put a 2 here, now it's balanced. Again, let's look at their states. NH4 is soluble in any compound, as well as for NO3. So we will say this is aqueous. Cadmium sulfide, we said S, we have a rule for S. It is not soluble with, it's not soluble with like cadmium, because it's only soluble with barium, strontium, sodium, potassium, and ammonium. It's only soluble with those. That's why it is not soluble, it becomes a precipitate. Now, what is the next step that we have to do? What is the extra thing that we have to do? If something is aqueous, what does that mean? It means that it is already an ion, like this. See, it has become an ion. So let's separate it again. Let's separate it again to make them ions again. Why? To see what has gone, like what has undergone reaction. The cadmium and the nitrate, is it aqueous? Yes, it is aqueous. Again, please concentrate. When it says aqueous, it means it has become ions. For ionic compounds, of course, what I mean. So it becomes cadmium. How many cadmium? 1 cadmium. What is the charge of cadmium? 2. It is still aqueous. Plus, what else do you have? Nitrate. How many nitrates do we have? 2 nitrates. 2 NO3s. Is it aqueous? Yes. Plus, ammonium. See, ammonium. Is it aqueous? Yes. So I'll become an ion. NH4. How many NH4? 2. Then sulfide is also aqueous. So sulfide 2 negative aqueous. Now the reactant side is done. Let's look at the product side. Is this still aqueous? Yes. How many NH4? 2 NH4 with 2NO3. This is aqueous, aqueous. Plus, if it's solid, it means that it is solid. It hasn't been dissolved. So we cannot make it ions. We cannot make it ions. So we'll write CDS as solid. Write it in a better way. A bit more nicely. CDS and S. Now, pay attention, everyone. Look at NH4. Has anything changed in NH4? Has it undergone any reaction? Of course not. What about nitrate? Nothing has changed about nitrate. So nitrate, in here, nitrate and ammonium, they haven't undergone reaction. But cadmium has changed from aqueous to solid. They have produced a new substance, which is cadmium sulfide, which wasn't present before. چی درست کردووە؟ مادەیەکی تازەیان دروست کردووە کادمیوم سڵفات کە پێشتر بوونی نەبووە و ناتوانین بگەڕێنینەوە، ناتوانین جارێکی کادمیوم سڵفات بتوێنینەوە. تەواو. The attraction between cadmium and sulfide is so strong that the water cannot separate them again. That's why only cadmium and sulfide has undergone reaction or have undergone reaction. They have undergone reaction. But the other ones, no. The other two, they haven't undergone any reaction. So we can say this. Nitrate and ammonium, they haven't undergone reaction. So we remove them from this equation. They are present in the solution. They are present in the container, but we remove them from our equation just to say that they haven't undergone reaction. Then, what do we call NO3 and NH4? Then NO3 and NH4 are spectator ions. Now, spectator. What does spectator mean? Ions, look at the definition, that do not take apart. See, they don't take apart. They just remain as themselves in chemical reaction and are found in solution both before and after the reaction. So even before the reaction, they are present. After the reaction, they are the same thing. We call them spectator. Where did the name came from? Spectator. They just look at it. They just watch. They don't do anything. They just remain in the solution without any reaction. كواتا spectator يعني شيء؟ يعني سيركر. سيركر. بس سيركر. هيش ناكر. What do we call this reaction? What do you call this reaction? Where we have separated everything. We call it overall ionic equation, where you have written the equation everything as ions. We call them overall ionic equation. Then let's see what is left. If we remove the spectators from overall ionic equation, what is left? Cadmium is left. Sulfide, they become from aqueous. Sulfide is left, and they have reacted together to form cadmium sulfide, but a solid, and we call this reaction as net. Only the net is left. Net ionic equation. Net ionic equation. Let me review it again. Explain it again. At first, you write the normal reaction. How? You know the compounds, and they are generally the solubles. They are generally solutions. When we react them together, it means that we have mixed them. Then when we go to the product side, we change places of the cations, or you can change places with the anions. It's up to you. As long as the cation of the first one bonds with the anion of the second one. All right, next. Then we try to separate them and write them as ions. Which one we are going to write them as ions? Only the anions, only the aqueous solutions. So if it says aqueous and it's a compound, just write aqu and separate them to become ions again. When you separate all of them, we call that overall ionic equation. Overall ionic equation. And that the ions which have undergone, the ions which they haven't undergone any reaction, they have remained the same without any change, we call them spectator ions. And the rest that is left will form net ionic equation. Look at another example also between potassium sulfate and barium nitrate. So this is how it works. Look at them. This is a solution. See, you don't have any precipitate. It's solution. It's barium nitrate. This one is potassium sulfate. This is also a solution. But what happens when we mix them? See, just directly, like instantaneously, when they mix, they have mixed the two solutions, directly a precipitate has formed. This white part is a precipitate. What is that precipitate? Barium sulfate. Barium sulfate is solid. So in here, what things have undergone like a reaction? The sulfate and the barium, they become barium sulfate, and NO3 and potassium are cancelled, so these are spectator ions. So for this equation, K and NO3 are spectator ions. باشا اسالوا يا شيا او انا spectator ion. هاي اكثر شيء كردو لقد يكل كردنيا يكسر شيء دروس بو يكسر بريسبيتيت دروس بو يكسر نشتو الشيء باش واسا. Let's look at another example. This example is, see, it can ask different examples in different ways. Sometimes in ministry exam question, it says what is the reaction between these two, like this. For example, it says reaction between cadmium nitrate and ammonium sulfide, what are the spectator ions? It just needs the spectator, that's it. Sometimes it says what is the net ionic equation? It only needs the net ionic equation. Or there's another type of question like this one. It says which two pairs, this is easy, but it needs a little bit more time. It needs time. Which of the following pairs represent a precipitation after mixing? So it means that which one will form a precipitation? Not all of them will form a precipitation. All right?
باش ما صار لسه برسيري سراني او رسمك بوشي او دوانا بلين بسبكتيت بوشي بلين يكتري ناقل كي لقل انو تريكه
لبروي شيء كي انو تريكه اكشلي تزورني عوقت واني اللي كان جاكات مثلا او سري شو امونيوم نيتريتك بوشي الين سوليبل خوي او سوليبل او بي على على اتراكشن بين دو ان بقوته يعني اسالي مثلا كالين بوتاسيوم وامونيوم spectator يعني attraction كان كما تيجي بولم
يعني
كيك بينن وانا attraction زور او كانت انا جارك اللي كان جاكاتو
يعني ويني كل قشتك وت ما صل بلا اتمنى لا او يكسر بتنيا نكسر تبلا سبكتيتا قريت يعني
تيجي من هذا attraction كبقوته بس بتشيا ازاني ك اجري هي بس او كذا ببرسبيت ببي تيبل كذا بفيش رجل
بس خوش
Don't worry, we have a lot of more examples. We haven't still solved the practices. We have many more practices. So for example here, NaCl and copper nitrate. When you look at them, what would be the possible reaction? Then it becomes NaNO3 and CuCl2. NaNO3 is always soluble. Why? because it contains Na and also NO3. But what about CuCl2? Cl is soluble, generally soluble, except with what? Except with silver, lead, and mercury. كواتا رياح. لقى silver هاتوا النخر، لقى mercury هاتوا النخر، لقى lead هاتوا النخر. So this, both of them are aqueous. So it's not A. It doesn't form a precipitate. Let's look at B. B says it becomes K and NO3 because charge of K is plus, NO3 is negative, and when we balance it becomes 2 plus. Copper carbonate. Since it contains K and NO3, it contains K and NO3, so this is aqueous. What about this one? We don't have a rule for copper, but we have a rule for CO3. CO3 was from rule number 5. Everyone, you can check out rule number 5. Rule number 5 contains copper, phosphate, and carbonate, phosphate, and silicate. Carbonates, CO3s, are generally insoluble, except with what? Sodium, potassium, and ammonium. But copper is not sodium, it's not potassium, it's not ammonium. So carbonate is normally insoluble. That's why this one becomes solid. So the answer is B. That's how you solve a question. You can go and solve these two as well. They are all soluble. Even when after that, they are all soluble. Nothing has occurred. All right. You can write that down.
Sure.
Yes.
What if both of the elements or ions doesn't have any rules?
There must be. There isn't anything like that. There's always some rule, right? Don't worry about that. All right. Let's look at the next question. Why there is a precipitation after mixing together two different soluble solutions? Why there's a precipitation? Why do they contact each other? I have answered that before. Then the answer is because when the attraction between the ions, the attraction between the two ions are greater than what? Than the ions and the water. So the water cannot separate them. All right. When the attraction is too high, I can write it down in another way so that you can understand this rule. We can say when the attraction of ions is not R is so great that water can't separate them from each other. All right. Try to solve this question by yourself and one of you gives the answer. The next question. Will a precipitate form if solutions of magnesium acetate and strontium chloride are combined?
May I answer?
Yes.
D.
Yes, exactly. Because if you write down the equation, everyone, let's say it says magnesium acetate. What is magnesium acetate? Mg CH3COO, but since Mg has a charge of +2, so it's like this. If it reacts with, so it's aqueous, of course, because it says solutions of magnesium acetate. Both of them are solutions. When they are combined with what? Strontium chloride. Strontium chloride SrCl2 aqueous. All right. It becomes what? So these two are both aqueous. It might become Mg Cl2 plus SrCH3COO by 2. So look at this one. Acetate, it's in the second row. If it's in any substance, inside any compound, it's directly soluble, so it's aqueous. This one, Cl. Cl is generally soluble, except with what? Ag, silver, lead, and mercury. So it hasn't reacted with any of those. That's why this one is, sorry, again, aqueous. So do we have a precipitate? No, we don't have a precipitate. So the answer is D. The answer is D. We still have more questions to solve. Let's look at practices. Practice 1, I'm going to leave it for you so that you can solve it by yourselves. But practice 2, I'll solve it by myself. Look at practice 2. It says write, always it says write net ionic equation. See what I'm going to do. We have potassium nitrate, KNO3, plus magnesium sulfate. See, this is how the question will be asked in ministry. There isn't any formula. You can see the formula is not given. Instead, the names are given. So you have to know the tables in order to take out the formulas. Even though it can be easier for you because it's multiple choice question,
Yes.
sometimes you can figure out the substances from those from the choices given, but still you have to be careful to memorize. If you memorize it, it's going to be easier, and you'll save a lot of time during the exam. Now, what would be the what's the possible thing when it becomes the product? It becomes MgNO3, but the charge of Mg is +2, so it will be MgNO3 by 2. لبرو Mg 2 plus NO3 minus 1 كاتب دوغيشة يكاكيشة أبب MgNO3 by 2 plus. What else do we have? K2 SO4. Now, if I want to balance it, I'll put a 2 here. Let's go on. Even if you don't balance it, it's okay. It's not very necessary here. Look at the states. It says, will a precipitate form if solution of these two are combined? If so, write the net ionic equation. So you will write, since there is NO3 here, then this is aqueous. Same thing, since there is K here, without looking at anything else, you can directly say it's aqueous. Then what happens to net ionic equation? If both of them are soluble, what is the net ionic equation? Let's write the overall first. Let's write the overall. Let's make all of them as ions. K, 2K, 2NO3, Mg, 2 plus, SO4, 2 minus, Mg, 2 plus, because it's aqueous, 2NO3, all right, 2K, and 1 SO4. So this is overall or total. Overall ionic equation. Which things are spectator ions? K and K, NO3 and NO3, Mg and Mg, SO4 and SO4. Everything can be cancelled. So all of them are spectators. All are spectators. None of them will react. Then what would you say for net ionic equation? We'll say no net ionic equation. So if there isn't any precipitate, if a compound is not formed that is insoluble, you will write no net ionic equation. Net ionic equation because everything is spectator ion. All right, I'm going to give you some time to write that down as well.
باشماس خلق شتكي بون امجي تيانية عنيكية تيانية
امجي تيانية بس شي تيا برادر كي كخر اما دائما قريت شي انت انا بسي برادر كي تيجي اسمون منها بابنا اللي ريا اسو فوركا تيجي لقال ام جي تو بروسر رولي شوارم اسو فور رولي شوارم اسو فور لتشيا على بعم سوليبل وانيا طالما لقال شي انسوليبل لقال كالسيوم سترونتيوم وباريوم افشتانه يخونه وتو مغنيسيوم كاته لقال مغنيسيوم شيا سوليبل شكوبيوتي بعم سوليبل وجيتي بس لقال بينجا كبينيو لقال هالشيء كتير بينيو سوليبل هذا ابي اللي بس بون من الرول بينجا كربونيته ياخذ فوسفات وجيتي لقال هاشتاج كابينيو بكسب له انسولبل حساب باش تجيت المكان لا غير السدان تيجي
غلط
اللي اكيدو question 3 is also for yourselves كذا بسياري دومينا نسيبتو برم اگر له 4 رقم كينا نسيو 4
بس یک 4 ما کی بو بینوسین
مامسا ئەتۆین خۆ دوایی بەجیا ئەنسەرکی پرسیاری 1 و 3 مان بۆ بنێری بزانین کە خۆمان هەرمان کردو ڕاست بێ
زۆر باش بەس ئەوشتم بۆ نێرم شكرا بەڵام پرسیاری چوارەمە بەحەڵکەین پرسیاری چوارەم هەرچەند زۆر ئاسانە بەڵام ڕەنگە ئێوە شتەکەتیان لە تێک بچێ when it says write net ionic equation for the precipitation of nickel to sulfur, it means that please write it down from ions until it becomes a precipitate. So we only need the net ionic equation. We don't know where it come from. We don't know the first compound that it reacted from. We only need the ions. So it's nickel 2. So nickel, it's 2 plus with sulfide as 2 minus. At first they were aqueous and they have become solid. Nickel sulfide, they have become solid. That's the net ionic equation. That's the result. That's all. But at this point, I have a question. If you reverse a reaction, like if you see a reaction that is reverse of net ionic equation, what would be that process? Exactly opposite of net ionic equation. What's that process?
Ionization.
Ionization, and we haven't studied ionization now. Something else. We have studied something else. First lesson.
Electrolyzing.
No. The first lesson, chapter 2. What's the first thing that we studied? If ionic compounds dissolve in water and become ions, exactly of this one, then dissociation. So for ionic compounds, you can write this down as a note. For ionic compounds, net ionic equation is opposite of dissociation. Dissociation was, for example, KCl becomes K and Cl. Dissociation was from solid to aqueous, but net ionization is from aqueous to solid. See the difference now?